All right. Now we need to find out which one's the smallest. I'm just going to show that at the critical value that it is smaller than this one. In other words, that this is greater than this, because we have very similar looking expressions at the two endpoints, looking just like an interchange of B and C. So I want to show is A plus the square root of B squared plus C squared greater than the square root of the quantity A plus B squared plus C squared. All of that under the second root. Without going into all the details again, I've shown this in a previous video, which will be in the same playlist as this one, that if you square both sides, it's going to keep things going in the same direction, at least with the types of numbers we're dealing with here. And then whatever I write here, when you backtrack, although it's for a related but not quite the same reason, the same thing will hold. That the inequality will be going in the same direction. So squaring both sides. Just going to cancel out the square root over here. And that will give us a squared plus 2ab plus b squared plus c squared on the right-hand side. On the left-hand side, expanding that. We'll get cancellation here. Cancel out the a squared, b squared, and c squared that we have from both sides. So that now we're trying to check whether 2a square root b squared plus c squared, is that greater than 2ab? Since a is greater than 0, and of course 2 is greater than 0, we can divide both sides by 2a. So this boils down to, is the square root of all of b squared plus c squared greater than b? Well, since c was strictly positive, then c squared is strictly positive, and adding that to b squared will give us something greater than b squared. Taking the square root of something smaller will give you a smaller square root. And since b was strictly positive again, square root of b squared is b. So, since we have a true statement there, it can be reversed. The reasons can be given. I've given them elsewhere in a different video in this series. And so we do have that this is less than this without loss of generality. It'll also be less than the value of t at the other endpoints. So this, in fact, does minimize t, this value of x, minimizes t of x on the closed interval 0 to c.